What's up, everybody? I'm Nick with Mad from Multirotors, and today it's time for part 2 of this how to build your first racing quadcopter walkthrough. I want to say big thanks to all my followers, subscribers. Share with your friends, like and subscribe us. We got to get more views so we can keep on helping out and working in this hobby. A big thanks to Multirotor Mania for supplying the parts for this review. Let's get started. Okay, so there's 3 basic programs you can use to run your flight controller. There's Betaflight, CleanFlight, and BaseFlight. BaseFlight is kind of dead, so we're going to focus on CleanFlight for the majority of this. Betaflight is great, but they update quickly, so if you're a new guy, we're going to use CleanFlight. So the first thing you're going to do is plug in your quadcopter and go over here to the firmware flasher. Now on this drop down, you're going to select the board type that you have. For this build specifically, I have an SP Racing F3. You may have a Naze. Research and figure out which one you have. Your second drop down is going to show you what version you want. I want to put the latest on here, so I'm going to pick the latest. Now, you have to go down here to hit load firmware online, because if you don't, then it can't find the firmware. And it'll pop up with all the details and specs of what's new on the software. From there, if everything works correctly, you can simply click flash firmware and it'll work. This little executing local arrays will pop up, and mine's working this time. If it doesn't work, there's a right above it says recovery lost communication. It shows you how to install it using the bootloader. So once it's done, it'll pop up saying programming successful. Fairly straightforward. If it doesn't, again, follow the recovery lost communication. It'll show you what to do to install the boot, to install the program using bootloader. Okay, once again, make sure you have the right firmware. I literally have been trying to flash this with the wrong firmware for about 4 to 5 minutes. Anyway, so make sure you have it flashed correctly, and then up here click connect and it'll open up. Now this screen is where I like to start, and then I work my way down the left side. You notice mine's moving, it has a magnometer, it's a full board. I just haven't calibrated yet because it's a brand new fresh flash. So the very first thing I'm going to look at, I'm going to reset the Z-axis so it's straight. I'm going to see what direction the quad tilts. Now I'm leaning this thing forward and backward, and it's tilting the wrong direction. It appears to be rotated 90 degrees. So the very first thing I'm going to do is come over here to the configuration, and I'm going to adjust the yaw. Now, I've already forgotten what direction it was, but I'm going to try 90 degrees. I'm going to hit save. If you don't hit save, you will lose your settings. And then I'll go back here to setup. Okay, so now it appears I'm completely 180 backwards. So back to configuration, 270 degrees, save and reboot. And then back here to setup. It'll say ready right here when it's ready. So now forward, backward, left, right. Okay, so that's oriented correctly. Now if you're going to be using auto level, or you plan to, what you're going to want to do here is calibrate the accelerometer. Now I'm not going to, but I'm still going to show you how to do this. So the first thing you need to do is make sure your quad is perfectly level, perfectly close enough. As you can see on the screen, it thinks mine is tilted slightly, which it kind of is, but that's okay. Calibrate the accelerometer, let it sit still, and it'll tell you right here that it's finished. If you have a full board, you can calibrate the magnometer as well, but it's going to have you rotated on 360 degrees on all axes. Alright, next. The ports tab. This is like a two-way serial transmission. So if you're using an OSD or serial RX, you're going to need to come in here. Now if you're using S-Bus or a satellite receiver, you're going to turn on this serial RX right here on UART2. Do not turn off data on UART1. This right here is your USB connection. If you turn that off, your controller will no longer connect to the computer. So you would put this to serial RX and then save and reboot. I'm not using a serial for this one, even though I normally do. So save and reboot. Make it a habit after every page to save and reboot. It just saves you time. After you're done with your ports tab and it says it's ready, come back here to the configuration tab. Now this is where a large majority of your settings are going to change. Obviously if you're building a quadcopter, Quad X, unless you're doing a plus tricopter, they're all here. But I'm building a Quad X. We already did the board and sensor alignments, so there's no need to change that any further. Now receiver mode. Back in my first video I drew out all the diagrams for different receiver types, okay? So there was the PPM, which was the one wire from receiver to the flight board. Serial, which is S-Bus and a serial receiver. or parallel PWM, which is one wire for every connection. This is where you're going to want to set what you're using and how you're going to connect it to the board. I'm going to be using PPM for this one, so PPM. Receiver provider, select which one you have. All I remember off the top of my head is Spectrum 1024 is DSM2, Spectrum 2048 is DSM-X, and then here's your S-Bus, some D, some H, depending on which one you're using. RSSI, Taranis users, or Futaba, if you want to use RSSI, this is where you would turn it on. That's a whole nother setup. GPS, again, a whole nother setup. 3D ESCs, if you're trying to build a 3D bird, then there it is. ESC motor features. I love CleanFlight and Betaflight because everything's well labeled. So the first tab here is motor stop. What that'll do is make the motors not spin when the quadcopter is armed. Now that's smart if you're learning because you can arm it before it takes off. However, you will find that when you're trying to fly in air mode or upside down and you kill the throttle, it's going to literally stop the motors and you have no control if it's not spinning. So use it with your discretion. Yes, no, it's up to you. One shot 25 is the protocol of how quickly the flight board speaks to the ESCs. Now, if you don't know, chances are your ESCs have it installed. If you try and plug it in and you're not getting the correct signal, then turn it off and see if that helps. Disarm motors regardless. If you're using a switch arm, that comes in handy. Now, minimum throttle. This is the lowest throttle it will give the motors. If you try to arm your quadcopter the first time and it takes off flying and you're not doing anything, it has that high of low throttle that it takes off on you. This is what you will lower. However, if you go below 1,000, your ESCs will not do anything. They'll just sit there off like you have motor stop on. Usually, for most of my builds, I drop this to 1050. That lets my motors keep spinning, but doesn't provide enough pop to get me off the ground. Your middle throttle is just that, what level it tries to operate at middle. If you're running a high expo or really high throttle amount, you can change this. It's all tunable to your needs. And the max throttle is 1850. I have heard of some people trying to squeak that higher, but there's really no point since the ESC inputs are 1000 to 2000, excuse me. Accelerometer trim you don't need to mess with. Battery voltage. If you're running a VBAT sensor, aka you have your voltage leads plugged into the flight controller board so you can see what your battery level is, this is what you would adjust. If you plug in your quad and sit on the bench and it won't stop beeping, this is why. You can simply turn that off and hit save and it'll stop beeping. If you do have it on, you need to set your cell voltage and your maximum. Be aware it's probably going to beep at you on the bench. Current sensor if you have one installed, I do not. Again, this is a basic build walkthrough. Loop times, don't worry about it. Not yet. If you get better and you start racing, you start learning, this is where you'll adjust your loop times, which is basically how fast the gyro and the PID loop resets itself and listens and programs. Down here's a couple other interesting features. You've got in-flight calibration for your accelerometer, servo tilt if you're running a gimbal, soft serial, which is if you need more of those USB type speaking ports, except the soft serial is slower. Sonar if you're running it, telemetry if you need it, 3D if you're still trying to build that 3D quadcopter. LED strip, if you want to run an RGB LED strip, meaning lights you can change colors and control, this is where you turn it on. It connects to channel 5, but again, that's another install, not this one. OLED display, I honestly have never seen anybody use one. I have used one to try, but it was kind of dumb. But then you turn it on, and then if you have black box, this is where it comes on as well. It won't run if you don't have this turned on. Channel forwarding, it lets you connect your auxiliary channels to servo output, so basically like a pass-through, and then a transponder if you're running a racing type flight controller. Now, save. Always, always, always save. Okay, so when you come over here to the receiver tab, the first thing you want to check is your channel map on this drop-down. Spectrum, Graupner, JR, Futaba, Hitec. Set it to whatever you think it needs to be, hit save, and then you're going to look at these little tabs. What these tabs are showing you is the input from your remote to your quadcopter. Now there are a couple things you need to keep in mind here. Number one is that your travel should be from about 1000 to 2000. You can see my throttle goes from 1088 to about 1900. To fix that, you go into your remote and just find your servo settings and extend them slightly. So for me, minimum throttle needs to come down a little bit further. Oh, too far. If you go too far, the channel will actually reset. So if you're in the middle of a roll and you push the stick too far, it's basically going to stop and go back to center, and it'll cause you to crash. So it's better to be a little bit short, but not too much. The other thing to check is direction. For example, I'm pushing left roll, it's going right. I'm pushing right roll, it's going left. So same place usually, go into your remote and find the reversing. That was the roll, which is ailerons. So now left is left, right is right. Down is still down, up is up. Oh, my yaw is backwards. So rudder, reverse. So now you can see I'm getting full travel, all the sticks, and this is also where you can check your switches. Ooh, I forgot this thing arms. So you can see my aux2 is moving with the switch. That's also my arm, and then my aux1. So this receiver gives me 6 channels available. And then from here, I go over here to modes, and I set my arm switch because I like to arm on a switch. You don't have to, but then you have to remember all the stick commands. I know that my arm switch is on auxiliary 2 channel, which this little tab right here will move if I change the channels. And then I want my range to be here to here, so when I click the switch down, it'll be over here around, well, I think it's 1100 input. And then I also like to have a beeper just in case I lose it. So there's beeper, and I'm going to put it on the aux2, but the opposite side. It's a 3-position switch. Middle is off, up is its beeper, and down is arm. So now that I've got that set and I like everything where it's at, anything else I want to add? I want to throw air mode on. It's a habit. I like it. And I'm also going to set it to come on when I arm the quad. Save. And then on to the next tab. Alright, the next tab is fairly simple, but again, it can get complex. We're going to click over here on the Motors tab, and what we're going to do is an ESC calibration. Take your props off. Not loosened, not slightly on, not tight. Take your props off. It says it right here. Remove all props before using this feature. So what you're going to do is click this little I understand the risks, which means if you hit yourself in the face with the propeller, it's your own damn fault. And you're going to take this master slider and run it all the way up. If you notice, all 4 ESCs just got their full throttle signal. From there, you're going to plug it in, and it's going to do its startup jingle, and it's going to stop halfway through. Once it's done that little jingle, you're going to bring it back down to minimum and let it stop beeping. So now the ESCs are calibrated for their high and low. You can test this by running up the master slider. Oh, sorry, mine's got to make 2 passes. Some ESCs require 2 passes like these did. All you got to do is do it one more time. Master to full and then master to minimum. Now you can spin it and your ESC or your motor should start spinning. This is a way you can check your motor direction and layout. So each one of these corresponds to which motor. One is 1, back right. Spin it up a little bit, check your motor direction. ESC2, ESC3, ESC4. Looking at mine, it looks like all of mine but ESC1 are backwards. So that's how you do your ESC calibration. Anytime you start having awkward flight characteristics or something just doesn't feel right, you can rerun this. It takes all of 2 seconds. Just take your damn props off. Once you get done with your motor calibration, you can unplug your battery again, and you're almost done. The last thing we're going to need to look over here is the PID tuning. Now, out of the box, these are pretty much ready to go. There are many videos on PID tuning, and honestly, I'm not that great at it, so I'm going to leave this alone. But there's basically 2 controllers. The P is action, the D is reaction. Sorry, the P is action, the I is reaction, and the D is prediction. So think of it like cause effect and trying to prevent that cause and effect. There's a lot of videos. If you're trying to figure out PID tuning, go find one. I might make one later. I don't know yet. The important things I want to go over here are these rates on the right. Roll rate, pitch rate, yaw rate. Boom, boom, boom. What these do is control how quickly it moves along that axis. Now, it comes at 0, but you might notice that's kind of slow when you go to fly. Keep in mind these are at maximum stick. This isn't at little inputs. This is big stick. So normally 0.5 is about average for a beginner. Most of my quads are running 0.8, but on beta flight, so it's a lot more aggressive. But you can change these to 0.5 and leave them alone. And if you try and fly it and it doesn't seem like it's rotating quick enough on an axis, that's where you would go to look at. After you've done that, you're pretty much ready to test everything out. You can go over here to the receiver tab, and you should check your inputs again. Check your arming position. You can disconnect the quadcopter from CleanFlight, plug it in, no props. Test everything without props beforehand. Check your arm, check your direction, make sure everything's level, works correctly. If it does, throw props on it, take it outside, and be very careful about it. If you get the crazy funky chicken, chances are you've either messed up the motor direction or the board orientation. The last thing I want to go over here is if you are requiring auto level, it's under the modes tab. You have angle or horizon. I don't remember exactly which is which, but I'm pretty sure horizon still lets you do complete 180 to 360 degree rolls, and angle limits you on how far you can pitch over. There's a whole website on CleanFlight and Betaflight. You can read up on these and all the different settings, but that's the basics of what you're going to need to get going in this system. If you have any questions, feel free to hit me up in the comments. Feel free to message me on Facebook at Woody's Builds. Check us out on Mad for Multirotors, and keep on flying, and do not give up on the hobby. It's awesome. Thank you.